Okay, in this video I will be showing you how to add vectors. Now the example that you see here, we actually did it in the last video, and it has a purpose. So let's go over it one more time. Okay, so here you have a vector going in the positive direction, so it's a positive vector, and here we have a vector going in the positive direction as well, positive x direction. So when they're both going in the same direction, you add them. 5 plus 5 is 10. But here you have a vector going to the positive direction, and here you have a vector going to the negative direction. So 5 minus 5 is 0. You have no vector. That's these two are examples of the x directions, because if you remember, let me draw. I'm going to draw a coordinate plane. It came out a little messed up. Let me erase it. I'll draw it again. Okay, so we have a coordinate plane. This is the y direction, and this is the x direction. And the y direction going up is positive, and the y direction going down is negative. The x direction going to the right is positive, and going to the left is negative. So that's what's going on in these examples. Alright, so here you have the vector going in the y direction going up 5 units, and this one is going in the y direction going up 2 units. So if they're both going in the same positive direction, you just add them like regular integers. 5 plus 2 is 7. And here you have a vector going in the positive y direction, and this vector is going in the negative direction 2 units down. So you add them like integers. 5 minus 2 is positive 3. So the vector is actually going up. But, and here's where the complicated stuff of vectors start. What happens if I give you, let's say, a vector going this way? Let's say this is 5. And let's say I give you now plus a vector going this way. Let's say this is also 5. In this situation, you cannot add them. The reason you cannot add them is because they're not going in the same direction. These vectors have different directions, so that needs to be taken into account. The point is, you need to have a vector in this type of direction. You always want a vector in the x direction, or you want a vector in the y direction. So you want a vector going to the right or to the left, and you want a vector going up or down. If the vector is not going right or left or up and down, then you have a problem. Here, this vector is not going in the y direction, and it's not going in the x direction. It's kind of slanted to the side. So what you need to do to solve this problem, what you need to do is find something called the components of a vector. Let me change colors. So this vector, if let's break it down into something called an x component and a y component. Every vector has an x component and a y component. And if you notice, this looks like a triangle. It actually looks like a right triangle. There's your right symbol. So to solve this problem, you simply use the Pythagorean theorem if you have the given sides. So this is the x direction, this is the x direction, this is the y direction, and this is the positive x direction. So this is the positive x direction, positive y direction, and you get this. So to solve this problem, what you need to do is you got to find the x and you got to find the y. But in order to do that, since we only have one number, you have to use trigonometry. So in this problem, you would actually have one more step, and that extra step actually involves an angle here, which we'll call theta. So you need this angle to find the x and to find the y. And I'm going to give you a few examples, but first let's do a very easy problem using the Pythagorean theorem. So let's say that you travel 1 kilometer north. So this is 1 kilometer going north. And let's say you travel 1 kilometer afterwards going, 2 kilometers to the right. So first you go 1 kilometer north and 2 kilometers to the right. What we want to find, remember we spoke about displacement? Sorry about that. Displacement, we mentioned that is a vector quantity, and displacement, you have to go from the starting position to the ending position. So the displacement, if you notice, again, you have a right triangle. To find the displacement of this, we need to use the Pythagorean theorem. So it's going to be a squared plus b squared is equal to c squared. A is going to be 1 squared plus b squared is going to be 2 squared is equal to c squared. 1 squared is the same as 1. 2 squared is the same as 4. C squared. 4 plus 1 is 5. That's equal to c squared. Now we need to find c by doing the square root of 5. That will give you c. So c is equal to, I'm going to plug that in the calculator, the square root of 5 is 2.24 approximately. 2.24. So what that means is that the displacement is 2.24. Okay, so we just found the displacement. If you wanted to find, okay, let me write it here, displacement is equal to 2.24 kilometers. If you wanted to find the distance traveled, the distance, you need to add everything. So the distance would be 1 kilometer plus 2 kilometers would be 3 kilometers. Okay, so this is your displacement. The displacement is 2.24 kilometers and the distance is 3 kilometers. One more thing. Remember that displacement has a direction. So this problem is actually not finished. We found the magnitude, but we also need to figure out the direction traveled. But that we'll do it later on. What I want to focus on right now, really quick, is how to add a vector. So first I want to tell you that a vector has a head, and this part right here is called the tail of the vector. Okay, so let's say I have another vector over here. This is the other vector. If I wanted to add these two vectors, in order to add the vectors, you need to connect the head of one vector with the tail of the other. So this is the tail of this vector, and this is the head of the vector. So if I wanted to add these, I'm going to get this vector over here, and this is the head of the vector. And let me actually use another color. Now the head of the vector, which is this, I'm going to attach it to, so this is the head of the vector. I'm going to attach it to the tail of this vector without moving the orientation of it. So there's the second vector. We have vector A and B, and then we need to find the resultant, or the displacement, from the where you start all the way towards where you end. That's your displacement. So that's how you add vectors, folks. You have to get the tail of the vector, the head of the vector, and place it on the tail of the other vector, and then you just connect the dots from the beginning to the end, and that will give you your resultant. Okay, in the next video I will provide more examples on how to add vectors.